Allergy sufferers. Clarinex-D is a medication whose purpose is to reduce the symptoms associated with a variety of allergies. In clinical trials of Clarinex-D, 5% of the patients in the study experienced insomnia as a side effect. A random sample of 20 Clarinex-D users is obtained, and the number of patients who experienced insomnia is recorded. A, find the probability that exactly 3 experienced insomnia as a side effect. B, find the probability that 3 or fewer experienced insomnia as a side effect. C, find the probability that between 1 and 4 patients inclusive experienced insomnia as a side effect. And D, would it be unusual to find 4 or more patients who experienced insomnia as a side effect, and why? So do you see that this is a binomial probability problem? If you take Clarinex-D, you're either going to have insomnia as a side effect or you're not. So we're going to call success, I'm going to write that up here just for reference. Success means you have insomnia as a side effect. Failure is going to mean that you do not have insomnia as a side effect. Now we're going to give Clarinex-D to a random sample of 20 people. So we're going to have 20 trials. Because those 20 people have been randomly selected, we can assume that those 20 people are independent from each other. So we have independence. Each trial is independent. Now the probability of success, if success is having insomnia as a side effect, then the probability of success is going to be 5%, because we know 5% of patients experienced insomnia as a side effect. So P is going to equal 5% or 0.05, which means the probability of failure is going to equal 0.95. If 5% have insomnia as a side effect, then 95% don't. So in question A, I'm giving Clarinex to 20 people, and I want to know what's the probability that exactly 3 have insomnia. So in other words, in question A, I want to know what is the probability that I have exactly 3 successes. Well, if we have exactly 3 successes, can I calculate that probability? That's what this formula is about, right? If I have 3 successes, then that's going to be the combination of the number of trials taken the number of successes at a time times the probability of success raised to the number of successes times the probability of failure raised to the number of failure. So in this particular case, this is going to be the combination of 20 choosing 3. So we'll be able to have 3 successes out of 20 trials this number of times, times the probability of success, 0.05, raised to the number of successes power. So 0.05 is the probability of success, and we're going to raise that to the number of successes power, 3, times the probability of failure, 0.95, raised to the number of failures power. If I have 3 successes, then how many failures would there be? 20 people are taking Clarinex-D. 3 of them have insomnia. So how many don't? So if having insomnia is success, then we have 3 successes and we have 17 failures. So that 17 right there is coming from 20 minus 3. Now, if I do the combination of 20 choose 3, that is 1,140. There would be 1,140 different ways of getting 3 successes out of 20 trials. We certainly wouldn't want to try to list all of those like we did here. We certainly don't want to do that. So I have 1,140 times 0.05 cubed times 0.95 to the 17th. So let's calculate that. So if I do that calculation, that is 0.0596 if I round to 4 places. And usually we will round to 4 places. So the answer to part A, if I give XD to 20 people that are randomly selected, the probability that exactly 3 have insomnia as a side effect is 0.0596. So about a 6% chance. Question B. Find the probability that 3 or fewer experienced insomnia as a side effect. Do you see the difference between question A and question B? So question A was just exactly 3. Question B is 3 or fewer. So question B, we're asked, what's the probability that X is less than or equal to 3 rather than just equal to 3? So 3 or fewer people having insomnia means it could be 3, it could be 2, it could be 1, it could be none. So in other words, this is going to equal the probability of X equals 0 plus the probability of X equals 1 plus the probability of X equals 2 plus the probability of X equals 3. So if I find the probability of 3, the probability of 2, the probability of 1, the probability of none having insomnia, if I add those 4 things up, that would give me the probability of 3 or fewer. So how do I find the probability of X equals 0? Well, I use my binomial formula. If X equals 0, then that's going to be the combination of 20, choose 0, times 0.05, that's the probability of success, and there would be 0 successes, times 0.95, that's the probability of failure, and if there's 0 successes, then that means there would be 20 failures. Now, if I do 20, choose 0, that's 1. So this right here is 1, okay? So I have 1 times 0.05 raised to the 0 power times 0.95 raised to the 20 power. And that is 0.3585 if I round to 4 places. The probability of 1 success would be the combination of 20, choose 1. And then 0.05 would be raised to the 1 power because there's 1 success. And then 0.95 would be raised to the 19 power because if there's 1 success, then there is 19 failures. So if I do 20, combination choose 1, that is 20. So this right here is 20. So if I take 20 times 0.05 to the 1 power times 0.95 to the 19 power, that is 0.3774 if I round to 4 places. Now I really should say is approximately equals right here instead of equals because we did round, and actually the same is true here. I should have said approximately equal. The probability of 2 people suffering insomnia, that would be the combination of 20, choose 2. 0.05 then would be raised to the 2 because there's 2 successes, which means 0.95 would be raised to the 18. If there's 2 successes, then there has to be 18 failures. So the combination of 20, choose 2 is 190. So this number right here is 190. If I take 190 times 0.05 squared times 0.95 to the 18th power, That is 0.1936. So again, to be clear for your notes, this right here is the probability of x equals 0 successes. This right here is the probability of x equals 1 success. This right here is the probability of x equals 2 successes, okay? And we already calculated the probability of x equals 3 successes. We did that up here in part A. That is 0.0596. So the probability of 3 or fewer successes is going to be this plus this plus this plus this. So this is going to equal 0.3585 plus 0.3774 plus 0.1936 plus 0.0596. And so if I add that up, that adds up to be 0.9891. So again, if I give XD to 20 different patients, the probability that 3 or fewer of them suffer insomnia as a side effect is 0.9891. What about C? Find the probability that between 1 and 4 patients inclusive experience insomnia as a side effect. So this time we're looking for the probability that the number of successes is between 1 and 4 inclusive. 1 and 4 inclusive means x has to be greater than or equal to 1 and x has to be less than or equal to 4. So that's going to equal the probability of x equals 1 plus the probability of x equals 2 plus the probability of x equals 3 plus the probability of x equals 4. Now we already know that the probability of x equals 1 is 0.3774. So this is 0.3774. We calculated that right there. We already know the probability of x equals 2 is 0.1936. We already know the probability of x equals 3 is 0.0596. We calculated that up there. So all I really need to know is what's the probability of x equals 4. So can I calculate that? Well, I'm going to do that kind of down over here. The probability of x equals 4, that would be the combination of 20, choose 4. And then 0.05 would get raised to the 4 because there's 4 successes, which means 0.95 would get raised to the 16 because there's 16 failures. If there's 4 successes, there has to be 16 failures. Combination of 20, choose 4 is 4,845. So this combination, 4,845, there's 4,845 different ways of getting 4 successes and 16 failures. If I take 4,845 times 0.05 raised to the 4th times 0.95 raised to the 16th, so 0.0133. So the probability of x equals 4 is 0.0133. So the probability of between 1 and 4 patients having insomnia is going to be 0.3774 plus 0.1936 plus 0.0596 plus 0.0133. And so that is 0.6439. D. Would it be unusual to find 4 or more patients who experience insomnia as a side effect, and why? Now, that question's actually a little bit misworded, in my opinion. What they really mean by this is, in our sample of 20, if we randomly select 20 of them, would it be unusual for 4 or more of them to suffer insomnia as a side effect? So it's not really about finding them, but would we have them in our sample, 4 or more? Now, how do we tell if something's unusual? We find its probability, and then we see if that's less than 0.05. So if the probability of 4 or more is less than 0.05, then that would be unusual. So what I have to find is the probability of X is greater than or equal to 4. Now, how would I do that? Well, one way that I could do that is I could find the probability of X equals 4, the probability of X equals 5, the probability of X equals 6, and so on all the way up to 20, and add that together. But that would be a lot of work. So an easier way of figuring this out is by thinking about the complement. The probability of 4 or more is the complement of 3 or less. So the probability of 4 or more successes would be 1 minus the probability of 3 or fewer successes. So we already found the probability of 3 or fewer successes. We did that in part B. So the probability of 3 or fewer people suffering insomnia is 0.9891. So the probability of 4 or more is going to be 1 minus that. And 1 minus 0.9891 is 0.0109. So the probability that if we randomly select 20 patients and give them XD, the probability that 4 or more of those 20 patients have insomnia is 0.0109. Is that unusual? Yes, that's unusual. So the answer here is yes, this would be unusual. So I want to point out something that will actually make our work a little easier. So was this problem hard? It's a lot, right? The calculations aren't that unbearable, but there's a lot to do, and there's lots of places where you could make a mistake. So there's lots of places where a mistake could occur. It's not really hard, but it's very, very tedious to calculate all this stuff. So it would be nice to have a way to kind of speed this up. And we actually do. We have a couple of ways that we could speed this up. If you look in the appendix of the textbook, from pages A3 to A10 has binomial probability distribution tables. So this page right here is page A3 in the appendix of your book. Now I have that available to you in my lab that you can print it off. If you go to my lab and you go to test formulas and tables, and if you print that off for test 2, this binomial table is right there handy for you to print. So I want to explain how this table works and how we could use it. And the truth is there's actually 2 tables here. There's a table from pages A1 to A6, that's table 3. And then there's a different table, table 4 starts at A7 and goes to A10, and both of these are about binomial probability distributions. And I'll explain the difference in just a minute. So here's how this table works. First of all, I want to compare it to what we did right here, that we calculated all out by hand. In this particular problem, N was 3, and the probability of success was 0.2. So N equaled 3 and P equaled 0.2. And we got 0.512, 0.384, 0.096, and 0.008 was those probabilities of 0, 1, 2, and 3 successes. Well, if I wanted to use this table, then I can go to right here in this far left column. I have 3 right here. That's where n equals 3. So this portion of this binomial table would be when we have 3 trials. And then if n equals 3, then x, the number of successes, could either be 0, 1, 2, or 3. And then what these are different possibilities for P, for the probability of success. So if my probability of success is 0.20, then if I come down to here, okay, where x equals 0, the probability of 0 successes is 0.512, 0, which is the exact same thing we calculated here, 0.512. And the probability of 1 success is 0.3840, which is what we calculated, 0.384. And the probability of 2 successes is 0.0960 and 0.096. And the probability of 3 successes is 0.0080, so 0.008. So this probability distribution, where n equals 3 and p equals 0.2, is already calculated for us in this table. So instead of me having to go through all the trouble calculating this, I could have just looked it up in this table. So I go to the appropriate section for the number of trials we have, and then I go to the appropriate probability of success. And I use that column in my table. So for example, we just did this problem where the probability of success was 0.05 and the number of trials was 20. So if I wanted to use the binomial table in the appendix, I would just have to flip back to where n equals 20. So that's on page A-6. So here n equals 20 and my probability of success is 0.05. So I'm going to be looking at this part of this table. So if n equals 20 and p equals 0.05, then the probability of 0 successes is 0.3585. That is the same thing we calculated right here, 3585. That was the probability of x equals 0 successes. The probability of 1 success is 0.3774, which we calculated right here. The probability of 2 successes is 0.1887, which we calculated, where did we calculate that? Well, I guess I goofed up on that one. Let me double check my calculation. 20, take 2, that's 190. 190 times 0.05 to the second times 0.95 to the 18th. Yep, I don't know what I did there, but I calculated that wrong. So that should have been, where's my whiteout? That should have been 1887 instead of 1936. Right there. And so incidentally, that means that's going to change these other answers here. This should have been 1887. And so if I re-add, that means this should have been 9842 instead of 9891. Right there. And that means this answer, again, that should have been 1887. So if I add that up, That should be 0.6390 instead of what I had before. And that means this answer should have been 1 minus 0.9842, which should have been 0158 instead of 0109. It still would have been unusual. Okay, sorry about that. I mean, obviously that, I just made a mistake typing it into my calculator or something. And so that's demonstrating, right, that there's a lot of places where you can make a little mistake that then causes you to get an incorrect answer. So we're trying to avoid that, which is the point of the table. Anyway, so 1887 is what that would be. 0596, we calculated that right there or up here, okay? And then for x equals 4, we have 0133, which is right here in the table. So again, my point is that we can look those probabilities up in the table instead of having to actually use that formula, which is going to make things a lot quicker for us and less apt to make one mistake in a spot that's going to cause you to get an incorrect answer. Now let me also show you table 4. So that was table 3, which does binomial probability distributions. Table 4 is actually called a cumulative binomial probability distribution. So what does that mean? So a cumulative binomial probability distribution is going to accumulate the probabilities as you go from 1 to n successes. So for example, for this problem right here, whenever we had 3 trials and the probability of success was 0.20, I want to explain what's happening here. So look at this table that we calculated, and I want to compare it to the cumulative. So what this table's telling me, when I look at 0, that's the probability of 0 or fewer successes. When I look at 1, that's the probability of 1 or fewer successes. When I look at 2, that's the probability of 2 or fewer successes. And when I look at 3, that's the probability of 3 or fewer successes. So the probability of 0 or fewer successes is just going to be the 0.512. But the probability of 1 or fewer successes would be the 0.384 plus the 0.582. So if I add the 0.512 plus the 0.384, that's 0.896. That's the value that you're seeing right there. So this is the probability of 1 or fewer successes. And then if I add 0.096 to that, that's 0.992. The probability of 2 or fewer successes is 0.992. And then if I add 0.008 to that, that's 1. The probability of 3 or fewer successes is 1. So the cumulative table is going to be useful for questions like question 3 here. What's the probability of 3 or fewer successes? Okay, what's the probability of 3 or fewer people having insomnia? Well, if I go to the part where x equals 20 and where p equals 0.05, if I go down here, the probability of 3 or fewer successes is going to be 0.9841. Now, when we calculated that before, we got 9842. So the table is saying 0.9841. So there's a slight bit of discrepancy. The reason for that discrepancy is the rounding. We rounded to 4 places, we rounded to 4 places, we rounded to 4 places, we rounded to 4 places and added that up. And so we're actually off a little bit because we always rounded to 4 places, and that made our 4th place off a little bit, okay? So 9841 is actually a little more accurate than what we got when we did this with the formula. And then, of course, I could also use that for this problem, okay? So 1 minus 0.9841 would be 0.159. Okay, again, there's not enough difference there to worry about, but again, the table would be a little more accurate. So example, use the binomial distribution table and or the cumulative binomial table to find the solutions to the previous two examples about the pop quiz and about the allergy sufferers. So that's what I did. I'm not going to write it out here, but that's what I did to show you, okay? So again, like for the allergy sufferers problem for part A, if I have 20 trials and I'm looking for exactly 3 successes, all I do is go to the regular table, not the cumulative table, 20 trials, 3 successes where P is 0.05 and I get 0.0596. There's that probability, okay? If I want to do the probability of 3 or fewer successes, then I go to the cumulative table. The cumulative table where there are 20 trials, 0.05 is the probability of success, and I go down to 3 or fewer, and that's the 9841. And then I can use that same value to find the probability of 4 or more. And if I want to find the probability of 1 to 4 successes, again, I could come back to my regular table and I can look up the probability of 1, 2, 3, and 4 successes and just add those things up in order to get the overall probability. So the tables can come in handy, but even more handy than that will be technology, which I'm going to show you in just a second. But before I do that, I want to mention just terminology that you have to be very careful about, the wording. So the phrase at least, no less than, greater than or equal to, all means you have a greater than or equal to scenario. So like in this problem, would it be unusual to find 4 or more patients? Well, I could say, would it be unusual to find at least 4 patients who suffer insomnia as a side effect? And that would mean the same question, okay? So at least, no less than, greater than or equal to, all means we're dealing with greater than or equal to, okay? If it's just more than or greater than, there's no equals to on that, okay? So would it be unusual to find more than 4? Well, that would mean greater than 4, not equals to. Fewer than or less than means less than. More or no more than, at most, less than or equal to means less than or equal to. And is exactly or equals or is means equals, okay? So it's really important that you interpret correctly, right? So depending on the phrasing of the question, it's going to mean one of these math symbols, either an inequality or an equality. And so you got to make sure you're paying attention to use the appropriate thing. Technology. Now, we have 2 different commands on our calculators that can help us with binomial probabilities, okay? And then we also have a command in StatCrunch that can help us with binomial probabilities. And so I want to show you this, okay? So this will be the first time we go to this place on our calculators, okay? If you look at the button right here, it says VARS on it, okay? The VARS button. The second of that VARS button says DISTR. That's for distributions. So in this case, we're dealing with a probability distribution. The second of the VARS button always has to do with probability distributions. So if I hit second and then the VARS button, that takes me to this screen, which lists a whole bunch of commands, and we're going to be using most of these commands during the semester, okay? So on my calculator, I have 3 different commands involving binomials. I have binom PDF, okay? That binom means binomial. PDF, that stands for probability density function, okay? I also have a binom CDF command. The CDF stands for cumulative density function. So probability density function, this is like the first table. This command is going to give me individual probabilities that I look up. But binom CDF is going to give me cumulative probabilities that I look up, okay? And then inverse binomial, we won't really use in this class, but that goes backwards. Okay, so if I knew the probability, it would tell me the scenario. Okay, so here's the deal. If I wanted to repeat the allergy sufferer's problem using the Binomial PDF and or the Binomial CDF command, okay, then the first question was, what's the probability of exactly 3 successes? Okay, so my command on that is going to be that I'm going to do Binomial PDF, okay, and the way this command works is this. Let me select that, Binomial PDF. Now on my new calculator, when I select Binomial PDF, I'm asked to enter the number of trials. So we have 20 trials. I'm asked to enter the probability of success, that is 0.05. And I'm asked to enter the value of X, that's the number of successes, 3. Okay? And if I choose paste, it puts this on the screen of my calculator. Okay? So I put N, then I put P, then I put X, the number of successes. That's the command that I'm going to use. So in this case, since I'm looking for the probability of X equals 3, that's going to be Binomial PDF 20, 0.05, 3. That's going to give me the probability of 3 successes. If you have an older calculator, you don't get the window like I did. You get Binomial PDF, so you have to type the part in parentheses in, 20, 0.05, 3. When I do that, I get 0.0596 if I round to 4 places. That's the same thing we got when we did it by hand with the formula. So that's the Binomial PDF command. Now for part B, we want to define the probability of X is less than or equal to 3. That's where the Binomial CDF command will come in handy. To find this, I'm going to choose Binomial CDF, and I'm going to use the same process. I'm going to put N, I'm going to put P, and this time I'm going to put the value of X that is the largest value. So 20, 0.05, and 3. That's going to give me the probability of 3 or fewer successes. So I go to distribution. I'm choosing Binomial CDF this time. 20 trials, 0.05, and 3 or fewer successes. So when I paste that, again, these look a lot alike. The only difference is this is PDF, this is CDF. So you got to pay attention to that. And I get 0.9841 if I round to 4 places. Now for part C. Part C is a little trickier to use the calculator for because we're doing between 1 and 4, okay? So I have 2 ways that I can think about that problem, okay? One is I could do it like we did by hand. I could use Binomial PDF and find the probability of 1 success, the probability of 2 successes, the probability of 3 successes, the probability of 4 successes, and add those up, okay? That's a bit of a pain, okay? Or I could do this. If I will find the probability of 4 or fewer successes, that would give me 0, 1, 2, 3, or 4 successes. And then if I subtract from that the probability of 0 or fewer successes, then that would subtract out the probability of 0 successes, which would leave 1, 2, 3, or 4 successes. Now, this is the simplest way of doing this. So for this, I could do Binomial CDF, and it would be 20, 0.05, 4. that would give me 4 or fewer successes. And then if I subtract off binom CDF, and if I do 20, 0.05, 0, that'll give me the probability of 0 successes. And if I subtract those two things, then that will give me the probability of 1 to 4 successes. So if I do binom CDF 20.054, that is 0.9974. So this first part here is 0.9974. If I do binom CDF, except change that to 0, that is 0.3585 if I round. And so if I take 0.9974 minus 0.3585, that gives me 0.6389. And that is approximately the same answer that we got by hand. We got 6390 instead of 6389. So we're off in that last place again, but that's because these were all rounded when we did that before. Okay, so this is actually a little more accurate. Okay. And then for the last one, we wanted to find the probability of 4 or more successes. So the way we do that is find the probability of 3 or fewer successes, which we found right here, and take 1 minus that. So there really wouldn't be any difference on that problem. We could use binom CDF, find this, and then take 1 minus that to get the probability of 4 or more successes. So there wouldn't really be any difference on how we do that part, other than we're finding this with binom CDF. Now, having shown you that, and I do like the calculator using that, but I think you're going to find StatCrunch even a little nicer to use. So I'm just in StatCrunch. Ignore this junk over here. I just opened it up, and so it doesn't matter what that is. It doesn't have anything to do with what I'm about to show you. I just needed to get into StatCrunch. So if I go to Stat and Calculators, well, this is all kinds of different calculators, and one of those options is right here at the top, Binomial. So if I select Stat, Calculators, and Binomial, this right here is a binomial probability calculator. So here's how this works. Let's look at the problem for the pop quiz. So for the pop quiz, n equaled 3 and p equaled 0.2. So I fill in n and I fill in 0.2. And if I say compute, what else you have doesn't matter. If I say compute, what I want you to see here is what we get is different probabilities. So for example, if I want to compute the probability of getting none of the questions correct, then I can change this to equals and change this to 0. The probability of getting none of the questions correct is 0.512, which is what we got by hand. The probability of getting 1 question correct, x equals 1. That probability is 0.384. The probability of getting 2 questions correct, x equals 2, 0.096. The probability of getting all 3 questions correct, 0.008. So I could find those one at a time. And it's kind of cool because while I'm at it, it's creating a graph of that. And by the way, notice that right now it's saying x equals 3. Look over here at the bar for x equals 3. It's red. That's what I found the probability of. If I change that to 2, now that's the bar that's red. Okay. If I change that to 1, now that's the bar that's red. So if I want to do the Clarinex problem, for the Clarinex problem, for part A, we had 20 trials. The probability of success was 0.05, and we wanted to know 3 successes, the probability of exactly 3 successes. So I would type 20 in here because there's 20 trials, 0.05 because the probability of success is 0.05. And if I want to know the probability of 3 people exactly suffering insomnia, then I'm going to say x equals 3. And when I compute that, I get this graph, and right there's the probability, 0.0596 if I round to 3 places. And again, notice the red bar. The red bar here is where x equals 3. For part B, we wanted to find the probability of x is less than or equal to 3. So all I have to do is change this to be less than or equal to. And looky right there, 0.9841 if I round to 4 places is that probability. And also notice the bars that are red now. That's less than or equal to 3. So the 3, 2, 1, and 0 bars are shaded red because that's what this probability is calculated from. For the last part of that problem, we want to know the probability of 4 or more successes. So I could change this to greater than or equal to and 4. So that's 4 or more successes, and that is 0.0159, which we found, and so that is unusual. The part C was a between problem, between 1 and 4 inclusive. If I want to do a between problem, look up here. I have a tab that says between. If I select that, what changes is what I have down here. So if I want x to be between 1 and 4, then I have the probability of 1 is less than or equal to x, which is less than or equal to 4. If I compute, then that is 0.6389. When we did it by hand, we got 6390 because of the rounding. So I do want to point out a couple of things that you're going to have to be very, very careful on, regardless of whether you're using the formula, you're using the table, you're using calculator, or you're using StatCrunch. The same mistakes are possible. And that is, again, paying attention to the wording. So if my question is, what's the probability that 3 or fewer suffer insomnia as a side effect, then that means less than or equal to 3 or fewer. And that probability would be 0.9841. Now, I could ask a very similar question, but it's really different. If I said, what's the probability that fewer than 3 of the 20 patients suffer insomnia? Fewer than 3 means not less than or equal to, it just means less than. So fewer than 3 would give me a different answer. That would be 0.9245. So fewer than 3 and 3 or fewer isn't the same question. Fewer than 3 really means 2, 1, or 0. And notice what's shaded in red. Fewer than 3 is 2, 1, or 0, which incidentally would be the same as less than or equal to 2. I get the same answer there. Less than or equal to 2, less than 3, the same result. So you got to pay very, very close attention to the words to determine whether you have just like a strict inequality of less than or greater than, or if you have a non-strict inequality where you also have equals to. Pay really close attention to that because that's going to change things.